To solve k plus 2 factorial over k minus 2 factorial equals to 1680. We will expand k plus 2 factorial in order to extract k minus 2 factorial from it. And this is going to give us k plus 2 times k plus 1. By definition, factorial is the product of numbers that reduce by 1 until we get to 1. Then we have, when we subtract 1 from k plus 1, we have k minus 1, and there is k minus 2 factorial. Everything over k minus 2 factorial. And that is equal to 1680. So that k minus 2 factorial cuts out k minus 2 factorial. And as such, we will be left with k plus 2 times k plus 1 times k minus 1 equals to 1680. Now, if all these are expanded, it is going to give us a quadratic equation which will take a lot of time to solve. So we are going to use a trick here. The trick we have to do with reduction. We want to reduce to quadratic equations while we make use of transformation. So we group the first and the fourth terms together. That is k plus 2 multiplying k minus 1. Then we group the second and the third terms together as well to give k plus 1 and k, and that is 1680. Then we expand each of the two groups. So multiplying k plus 2 and k minus 1 is going to give us k squared plus k minus 2. Then multiplying the other pair, we are going to have k squared plus k equals to 1680. Now what we try to do is that in the second bracket, we will subtract 2 and add 2. We want to make it look like the first one so that the substitution can work well. So in the first one, we still have k squared plus k minus 2. And in the second, we will write k squared plus k minus 2 and plus 2. And everything is equal to 1680. At this point, we make the transformation. Let k squared plus k minus 2 be p. Substituting into the above in order to transform the variable, we have p for the first bracket, while the second bracket is going to be k squared plus k minus 2 is p. So we have p plus 2 equals to 1680. We have now successfully transformed the variable to p. So we open this bracket and simplify to give p squared plus 2p equals to 1680. Then rearranging, now that we have reduced from quadratic equation to quadratic equation by the transformation, we have p squared plus 2p minus 1680 equals to 0. We are going to use the discriminant to check if these have a real solution. The discriminant d is b squared minus 4ac, where a is the coefficient of p squared, which is 1, b is the coefficient of p, and that is 2, while c is the coefficient, the constant term, which is negative 1680. So applying this in the discriminant formula, we have the discriminant to be 2 squared minus 4 times 1 times negative 1680, 1680. So that d is 4. The product of negative 1 and negative 1680 gives positive 6720, altogether giving 6724. In this case, the discriminant is greater than 0. Being greater than 0 means that the roots of the equation p squared plus 2p minus 1680, we have real roots. Also, 6724 is a perfect square. And if it's a perfect square, it simply means that we can use factoring method to solve the quadratic equation. In using the factoring method, we look for the factors of negative 1680 that will add up to positive 2. And these are positive 42 and negative 40. So p squared plus 2p minus 1680 equals to 0. We factor as p plus 42 times p minus 40 equals to 0. So that by the zero product property, p plus 42 is 0 or p minus 40 is 0, which means that the values of p can be negative 42 or p can be positive 40. Remember, from the transformation we made, we have that k squared plus k minus 2 is p. So when p is negative 42, we have that k squared plus k minus 2 is equal to negative 42. This means that k squared plus k minus 2 plus 42 equals to 0. And that simply means that k squared plus k plus 40 equals to 0. Trying out the discriminants as we did earlier on, where a is 1, b is 1, and c is 40. The discriminant d is 1 squared minus 4 times 1 times 40. This is going to give us 1 minus 160, which is minus 159. Here the discriminant is less than 0. And if the discriminant is less than 0, this means there is no real solution for k. When p is negative 42. We then try the second one. And that is when p is 40. When p is 40, we're going to have k squared plus k minus 2 equals to 40, such that this becomes k squared plus k minus 2 minus 40 equals to 0. Then k squared plus k minus 42 equals to 0. Using the discriminant here also, we have the discriminant d to be b squared, which is coefficient of k, 1 squared minus 4 times a, which is the coefficient of k squared, and that's 1, and times negative 42, which is c, the constant term. The discriminant here is 1 plus 168, which is 169. So the discriminant is greater than 0, which means that there are real values for k at this point, and the discriminant is also a perfect square, which means that factoring techniques can work for the equation k squared plus k minus 42 equals to 0. So we have k squared plus k minus 42 equals to 0. When we look at negative 42, the factors of negative 42 that will add up to positive 1. These factors are negative 6 and positive 7. And therefore, k squared plus k minus 42 equals to 0. We factor as k plus 7, k minus 6 equals to 0. Or k minus 6, k plus 7 equals to 0, as the case may be. And by the zero product property, k plus 7 is 0, or k minus 6 is 0. So that k is negative 7 or k is positive 6. Then we're going to test the consistency of these values with the original equation that we are trying to solve, which is k plus 2 factorial over k minus 2 factorial equals to 1680. Now, when k is negative 7, and we substitute negative 7 into this, we will be having negative 7 plus 2 factorial in the numerator and negative 7 minus 2 factorial in the denominator, which is going to give us negative 5 factorial and negative 9 factorial. There is no solution here, as factorial is only defined for positive integers. Therefore, k equals to minus 7 is not a solution. And as such, we test the other value, which is positive 6. So if we have 6, we're going to have 6 plus 2 factorial over 6 minus 2 factorial, which is going to be 8 factorial over 4 factorial. This is the solution to the value, as 8 factorial is 8 times 7 times 6 times 5 times 4 factorial over 4 factorial, with 4 factorial cancelling out, and the product is 1680 of 8, 7, 6, and 5. The conclusion is therefore that the real value of k, this time around the only real value of k, is 6. Make sure you leave your comments by if you enjoyed the video, share it, and subscribe.